So guys, the next topic is vector, which is a very important topic, though it is a mathematics part something, but it is being of immense importance in physics. So we do a exclusive session on vectors, very important topics, and it is very mandatory to you to understand each and everything about vectors. So that's why I am doing it very exclusively. So the thing is, let's come to the point. Vector. So first of all, we talked of physical quantities so far. Physical quantities, as I told you, these are the quantities which can be measured. In physics we learn those physical quantities only which can be measured. So these are of two types. Okay, say for example, I said a body has a mass 5 kg. So this is a physical quantity. Okay, we can measure it now, mass of boy. Or I say the length of a cloth is 10 meter, so we can measure actually the cloth length, so that is 10 meter. So these two are physical quantities, and you can know that there is a magnitude and there is a unit. We talked in previous chapter of physical quantities these in descriptive manner. So physical quantities are of two types. One is scalar, one is vector. Okay, don't worry, I'll explain you each with example. Say for example, I tell you that there is a rod and its length is 2 meter. So it's enough. Okay, if I place this rod like this, horizontally, vertically, and in inclined way, the length of rod would be only 2 meter, and the description is enough. If I say the length is 2 meter, this description is enough. Okay, irrespective of the position of the rod. But if I say that, okay, there is Qutub Minar in Delhi, and I ask somebody to meet me 2 kilometers away from Qutub Minar, so does the description is okay? I ask this person to meet me 2 kilometers away from Qutub Minar, so can he ever be able to meet me? Because no, because the thing is 2 kilometers can be here, 2 kilometers can be backward, can be sideways, can be anywhere on earth, so it would be very difficult. So here's only 2 kilometers is not sufficient enough, suffice enough. You need to give the direction as well, the 2 kilometers right, left, forward, backward. So direction is important in the second case. Actually the second case is an example of vector quantity, and the first case is a case of scalar quantity. Actually first one is just the length, so that is a distance only. Second one is a displacement. You had heard these things in your previous classes as well. So simply, scalar quantities are those quantities where you just need to have only just magnitude to describe it, like time, like length, like mass. So these are only magnitude, where you only need magnitude. Okay, like mass, like time. Whereas vector quantities are those which need magnitude plus direction, magnitude plus direction, plus direction. I'll give you another example of that. First one is displacement, velocity, acceleration. There are n number of examples, but let's talk about vector quantities more precisely. So vector quantities, I'll give a famous example, force. So vector quantities examples are force, velocity, okay, acceleration, displacement. So displacement, acceleration, and there are many. You would learn them one by one, as the physics of proceed. You would have many knowledge and etc. So let's take the example of force. Okay, excuse me. For example, force, I said I applied a force of 10 Newton. Newton is the unit of force. I hope you know that from the previous class. So I said I applied a force of 10 Newton. What would happen to this body? Where does it would go? So does this description is enough or suffice enough? You would say no. Tell me the direction. Whether you apply force from here, this side, whether you apply force from this side, whether you apply force from this side, whether you apply force from this side, tell me at least the direction. So in case of force, only magnitude is not sufficient enough to talk about the impact. You just need to have the direction as well. So this one is a vector quantity. Okay, now let's talk about the description of a vector. Description of a vector. How do we represent vector quantity in physics? How do we represent or describe a vector quantity? Actually, we represent it by an arrow. We represent a vector quantity by an arrow. Okay, so where the length of arrow would determine the magnitude of that quantity, that vector, and the arrow would determine the direction. Arrow would give you the direction of that vector. If I say there's a velocity vector, okay, and say for example this is a velocity vector and this length is 2 centimeter, so this represents 5 meter per second. And what is the direction? Can you see that? North. Direction is north. So just tell me what would be the, if I draw another vector, velocity vector, and its direction is again north, but the length of this vector is 4 centimeter. So what would be the magnitude of the velocity in this case? What would be the magnitude of velocity in this case? Velocity magnitude. Then you would actually you need to look for reference this point. Here what is the magnitude? 5 meter per second. And what is the length of the arrow? 2 centimeter. So here the length is getting twice, the magnitude is also getting twice, because the length is actually representing the magnitude. So here the velocity would be 10 meter per second. You are getting the feeling what I'm trying to say? So in this way we represent a vector by an arrow. Okay, great. Let's move more ahead. And there are some things which you need to know in case of the vector. We learn if we are learning vector quantities, so there are some of the things you need to learn. Just say for example, if I say this is some vector, okay, this is the xy axis, nothing more than that. So I said a vector, here it is a vector A, and we represent, if I say vector A, so we represent it by the letter A, and above it a small arrow. Above the letter A there is a small arrow which actually tells this is a vector quantity. So representation of a vector in in a letter form. The line is a graphical form, so in letter form is a diagrammatical form. We have to represent by the letter, and above it a small arrow. So see, if I say that vector is like the magnitude of that vector A, it can be anything: acceleration, velocity, force. the magnitude is like 10. So the complete description of that would be, if this angle is 30 degree, so 10 is the magnitude, and this vector makes 30 degree. We call this as, say this is east, this is west, this is north, this is south. 30 A is magnitude is 30 degree, and vector A is 30 degree north of east. Okay, I am proceeding 30 degree north of east, and the same can be called as, 60 degree east of north. If you moving from north, so this is actually 60 degree east of north. Both are same thing. So I'm just giving you the representation of a vector. Okay, so now you have to tell me the another one. Okay, you have to tell me that. Just look into it. If I say there is a velocity vector and I am representing it by this, and then this I am representing is by, say for this is 15 degree, and east, west, north, south, you know that I gave you, and this is a vector, and the magnitude of a vector is like, say for example 5 meter per second. This is a velocity vector. So what would be its direction? Give me its two direction. How would we represent it? The velocity vector is actually like, you can say that this is 5 meter per second velocity, 15 degree north of west. Can you see that? 15 degree a vector is like 5 meter per second, 15 degree north of west. Or similarly, you can also say that it is 75 degree west of north if you move from north. So did you get the thing which I want to say to you? Clear? Okay, let's move more ahead and talk more things over the vectors. Okay, now if I talk of two vectors, which is important, then we'll talk of types of vector. But first of all, let's take two vectors. If there are two vectors, okay, so if I need to draw two vectors, just say for example I draw one vector is like this, one vector is like this. So what are the points you can make about A and B? What about their magnitude and direction? Okay, more or less you can see that their direction is same. So they are parallel actually. So direction is same. Parallel lines have the same direction. Both are going towards east. Okay, yeah. And magnitude of whose is greater? B and A. Of course, you go by the length. So of course the magnitude of B is greater than the magnitude of A. So this is the one more point. Okay. So if I talk of the vectors, so magnitude of B is greater than magnitude of A. Okay. Now second important point which I need to make here, angle between two vectors. Okay, this is the important thing, angle between two vectors. Between two vectors. So if I'm talking of the angle between two vectors, so for actually knowing the angle between two vectors, we look for the angle which is made by the tail to tail. Say for example here it is 30 degree, so I would say 30 degree is the angle. But if I draw like this, so would the angle be